Okay, so to understand how to find the limits of rational functions when x approaches infinity or negative infinity, you need to understand these three rules. When the degree of the numerator is greater than the degree of the denominator, then the limit does not exist. So that means if n is greater than m, then there's no limit. But if the degree of the numerator is less than the degree of the denominator, then the limit is equal to 0. So that means if n is less than m, then it's 0. But what happens if the degree of the numerator is the same as the degree of the denominator? So that means what happens if n equals m? What if this is 2 and 2 or 3 and 3? Then all you have to do is take the coefficient of that term. So it would be a over b. So if this n equals m, then all you have to do is a over b, and that would be the limit. Okay, so let's solve the first question. Limit as x approaches infinity of 3x plus 1 over x minus 4. Just by looking at it, we know the answer is 3, because the degree of the numerator is the same as the degree of the denominator, and 3 divided by 1 is just 3. But I want to show you another way you can solve it. If you happen to forget your rules, if you don't remember if it's less than, if the numerator is less than the denominator, what do you do if it's greater than? If you somehow forgot your rules, there's still another way for you to solve it. It's called the end behavior method. So the end behavior method just takes the first term, or the term which has the highest degrees. So you just take the 3x, you take 3x over x, which is equal to x. So now your end behavior would just be y equals 3, because that's what we got here. And now you can just solve for x approaches infinity when y equals 3. So when y equals 3, the graph of that would look like just a straight line across at y equals 3. So when x approaches infinity, it's going to be 3. No matter what value it approaches, it's always going to be 3. So we can just say the limit as x approaches infinity of 3x plus 1 over x minus 4 equals 3. Okay, question 2, we have the limit as x approaches infinity of 3x cubed minus x minus 1 over x plus 3, and we have x approaches infinity of the same function. So just by looking at it, the degree of the numerator is greater than the degree of the denominator, which means it does not exist. But remember, infinity is not a constant, so technically infinity as a limit does not exist, but we can still find if it's infinity or negative infinity that it approaches when x approaches infinity. So let's just use the end behavior method again. So let's take the term, the highest degree term of the numerator, which is 3x cubed, and divided by the highest degree term of the denominator, which is x. So this turns out to be 3x squared. And it's going to be the same for both because it's the same function. So now if we graph this out, if we just sketch it, it's going to be something like this. And when x approaches infinity, y is also going to go to infinity. And when x approaches negative infinity, y also goes to infinity. So in this case, as x approaches infinity and negative infinity, the result becomes infinity on both sides, but it's not going to be the same for every case. So let's just write out the answer. Limit as x approaches infinity, let's just say as f of x, this is going to equal infinity, and the limit as x approaches negative infinity also equals infinity. So even though it does not exist, you can tell if it's at infinity or negative infinity. So let's just box in our answer. Okay, so let's solve the limit as x approaches infinity of 4x squared minus 3x plus 1 divided by 2x cubed plus x minus 1, and when x approaches negative infinity. So again, just by looking at it and knowing our rules, the degree of the numerator is less than the degree of the denominator, which means that the limit approaches 0. But let's show our work for that by using the end behavior method again. So So when we take the highest degree term of the numerator, we have 4x squared, and divide it by the highest degree term of the denominator, we have 2x cubed. And this is just going to turn out to be 2 over x, because this x gets canceled out, and 4 over 2 is 2 on the top. So if we graph this out, this is going to be somewhat around like this, and a horizontal asymptote at y equals 0. So as you can see, when x approaches negative infinity, it gets super close to 0, and when x approaches infinity, it also gets super close to 0. So we can just say that the limit as x approaches infinity, and once again let's say f of x, 2 over x, or not 2 over x, this becomes 0. And when limit as x approaches negative infinity, this also equals 0. Okay, so the fourth question we have limit as x approaches infinity of 4x cubed minus 2x plus 1 over x squared minus 2x plus 1. And same thing for x approaches negative infinity. So again, just by looking at it, we know this limit does not exist, but technically it does because it's either infinity or negative infinity. So the end behavior method. So the highest degree term of the numerator is 4x cubed, and the highest degree of the denominator is x squared. So when you simplify this, you'll just get 4x. And now we just have to find the limits of infinity and negative infinity of 4x. And 4x looks something like this, just a linear line, linear equation. So as you can see, when x approaches negative infinity, all the way down here, this is going to go to negative infinity. And when x approaches infinity, this is going to go all the way to positive infinity. So you can just say that the limit as x approaches infinity of f of x equals infinity, and the limit as x approaches negative infinity, this time it's not the same, it equals negative infinity. So if you happen to forget your rules, just use the end behavior method, and it'll be a lot simpler. It'll either be, most of the times it's going to be just a quadratic or just a linear equation like this, and you can just see where y gets to when x approaches infinity and where y goes to when x approaches negative infinity. So in this case, negative infinity goes to negative infinity, and positive infinity goes to positive infinity. So we can just box in our answers.